let's bring all these in real quick. Find the number of possible 5-card hands that contain the cards that are specified. So basically, we know out of the 2,500,000, a lot of numbers.
2,598,960.
Thank you, Colin. One thing he remembers is something about gambling. If that's all you remember from me, Colin, you'll be fine.
Counting cards. Teach us.
What was the movie, 21?
Yeah.
Yeah,
That's
no,
Northwest Indians.
you're like Kevin Spacey.
But taller.
Yeah.
And that is like evil.
Just shake my
But you
head.
do teach math, so.
Stacy is like definitely confused.
So what you're looking at here is how many occurrences can happen within the 2-point-something million 5-card hand possibilities that all 5 face cards can, you get all 5 face cards. Now, when I'm looking at 26, we have to figure out that all you want to get are face cards. Yes, ma'am?
Is this estimating what is the chance or how many combinations?
How many combinations? And that's the difference between now and then we start talking about probabilities. When we start talking more about probabilities, it gets to be, the wording will have to be different. So if I'm looking at, I want to get face cards. Okay? I want all 5 of them to be face cards. How many cards are there in a deck of cards that are face cards? How many do you want? 5. There are 12 cards in this deck that are face cards. You want all 5 of them. Bless you. So the probability that I deal Maddie 5 face cards is, well, it's not probability, but she got 2. Whoa. Hi, how are you?
I got a good hand.
You did get a good hand there, not bad. Here, play against your good The number of times that it can occur, or the number of possible combinations of it occurring then, would be, there are 12. Hey, it's about You can come in if you play blackjack. Ready? All right, here you go. All right, we want. Look at it. Hit. Ooh, 19. I don't know if you want to stay there. Oh, you're sitting on a 6, aren't you? You're over. Ooh! Let's go. 15, 17. I'd sit on a 17.
All right, fine.
You have 6, don't you? Do you have 6?
Probably look.
Did I look? Did I? So I'm at 14. Dealer has to sit on 14. 16. Does dealer sit on 16?
Yeah. No.
No, so
Well,
again.
depends,
Oh, I'm
actually.
over to you.
They usually sit around 17.
You beat the champ.
So I'm 17.
You're something. Thanks.
I don't know what soft means.
Really? You did.
It is not my rule. They tell me not to do that.
See what?
The school's so broke, we need to, like, maybe hand out paper clips like that. You gotta get that.
Oh, you bad children not going to take your park test. Oh, you bad children. You did a bad thing. I know.
Why did they just call me down? Okay, they didn't get me on already.
Alright, so does that make sense there? You're just looking at how many cards in the deck are face cards. Of that, you need 5 of them, so how many combinations are there? 12, choose 5. Yeah, I kind of love it.
Yeah, it keeps saying that they don't go up into during AP class. They all have it first.
Yeah, they should.
Like,
If they would,
yeah,
if
so
they-
all can't go to
if they would switch us to a different hour, then we could all go, but they keep putting it in the same place, and that's why we
We
don't go.
wait until the 23rd.
Yeah, we have to wait till the 20.
Just keep waiting. They're just wasting paper. They're killing trees.
Yeah, for real.
4 aces and 1 other card. Now, look at the way this one is worded. Notice what's in between there. It says, and. Did you guys win? Did you see one?
Wait, so what was the first? You can sing, but it's alright.
You have the and thrown in there. So if you're talking about and, you want two separate things to occur. When you have two separate things that want to occur, what do you have to do between those two different events? That's the multiply. So in here, you have to play word for it.
It took 2 hours.
3.4. What is Lord?
So, how many aces are in a deck of cards?
I need to pick my card. You chose to pick for me.
How many of them do you want?
4.
So it's 4, choose 4. Then there's another event that has to occur in tandem.
48, choose one.
48, choose 1, very good. Because there's 48 cards left, and you just want one of them. Whatever that multiplies out to be, you're done.
48.
Sure.
Yeah, that's my sense.
One ace and 4 other cards, none of which are aces. So if you're looking at this, that's a real crappy hand in poker. Well, I guess it could be okay.
It could be 1, 2, 3, 4.
True, it could be a straight, doesn't say it isn't. How many aces are in a deck of cards?
4.
How many of them do you want?
1.
So it's 4, choose 1. There's another event that has to occur, so it's multiplying.
48.
Oh, 58.
I said 48.
I heard she said like 50, and like mumbled together.
Now, here's the deal. 51, you don't want aces, so you got to pull out the 4 aces, which leaves you 48. Choose how many?
4.
Oh, show.
You get a lot.
You get a lot of combinations there.
770.
And a partridge in a pear tree. Good job. 2 aces and 3 kings.
So 4, choose 2, times 4,
4 choose 2, 4 choose 3?
Yeah.
Should be right.
Hey.
Pretty good. Actually, the better full house would be aces over kings. Now the last one. Everybody okay on 29?
Yeah, I didn't quite understand
Yeah.
the last one.
The last one's really kind of weird. I don't know if I like how it's set up here. You want 4 of a kind and 1 of a different kind.
So 4 choose 4. I did 13 choose 4.
13 choose 1.
And then I did 39 choose 1.
It's 13 choose 1. If you think about it, you have 13 of each
Because you're choosing
of
one
each
of the
suit.
4.
Yeah.
You choose 1 of them, and that's how there'll be, there's 1 of a kind across each of the suits. It's a matter of picking 1 of the 13 that you're looking for, 1 of a kind. So you pick 1 of the 13 cards that are here. So it's 13 choose 1. You're picking 1 of them.
Maybe it would be times.
And then be times because it's the and 1 of another kind. So how many are left then?
12, choose 1.
Is it 12 or I thought you had, because you took out the,
Would you only get one other card though?
you get 1 other card, but you have the, what is it?
Would it be 48?
Yeah, I did
1?
48 choose 1.
Never liked, yeah, because it's 48 choose 1, yeah. I've never liked this wording on this.
But what do you have to account for the fact that they're different?
Because you're picking, this is built in to like a fractional amount of, if you think, is it 52 over, yeah, so you have the 52 over 4, and that gives you the 13, yeah. What did you get?
I mean, I got the same answer, but I did 13 choose 1, times 4 choose 4, times 48 choose 1. 4 choose 4 choose 1.
Yes, that makes more sense. Here's why that makes more sense. Pick your card, 2 through ace. Of that card, you want to pick all 4 of them. Does that make sense? And then of that card, you want to get 1 more card because there are 48. Choose 1. I really like that. I never would have thought of that. I think that makes much more sense because you have 3 separate occurrences that are happening. You're picking a 4, So you've got a 4, which means you want to get
On the other fours.
Oh, I did it.
all the other 4s.
I think this is cheating.
What's that?
Not cheating.
It's only cheating if you get caught.
True.
So if I did it, are you like, you know, playing? I did that, would you consider it cheating?
Yes. So,
I would think things be.
so you've got all, you picked a card, then you want to get all 4 of them, and then you want one other card. So you've got 4 of them here, and then you got 48 left. Because 4 choose 4 is 1. It cleans that up because it makes it, even though this is equal to 1, that's a really nice way of thinking about it. I never thought of it. I think that cleans it up. That's really good.
What's 29 is, would it be 4 choose 2 for 20, for 29?
Yeah. 4 choose 2, 4 choose 3. All right. Are those okay then? All right. How'd you know the word props?
I got all of it.
Way easier.
Yeah.
I didn't get 50.
50.
I did 50. 2
Cars. You're buying a new car, there are 7 colors to choose from, 10 types of optional equipment you can buy. You can choose only 1 color and afford only 2 of the options. It doesn't say that you're going to pick at most 2, it just says you're picking 2. Okay? So you're going to choose 2 options. So if there are 7 colors, how many are you choosing? 1. So would that be 7 choose 1?
Yeah.
Okay. And then these are in tandem with one another. They're separate events that occur at the same time, so we have to do what? Times. How many options are there?
10.
So it's 10, choose 2.
Yep.
That should work.
315.
944.
Oh.
I wish it.
You and me both.
Can you do me a favor, please?
No, it's too tough. An art contest. I should enroll in an art contest for the blind. No, blind judges. That wasn't a, I meant, no, I'm making fun of my artistic skills. Because nobody wants to see it.
Say artistic.
I apologize.
No, it's just weird because like I just learned how to like read Braille.
Oh, cool.
So like I thought about it, I was like, what if they can't see it? And then I was like, what if they made like described paintings out of Braille?
Now, it's a silly question. Why is there Braille on the drive-up ATM machine?
Yeah, they should be driving.
I mean, I guess the dog can be driving. I don't know.
Wait, is
Yeah.
I guess maybe there's like some blind person who wants to get the money. And
I guess you could like.
Oh, you're right. Test. The 4 works judged will be displayed at a local gallery. How many ways can these 4 works be chosen from the same artist's collection? What's the first thing you have to select? The 6 artists. You're picking 1 artist. So it's a 6 choose 1.
yeah, I don't like this one.
And you want another thing to occur then.
4 choose 5. 5 choose 4.
Wait, I thought it was saying
What if they
like 4 works. Like there could be 4 works from different.
I'd be down.
If you read it, they're saying they want there are 6 artists, 5 works of art in an art contest. The 4 works judged best will be displayed in the local gallery. How many ways can these 4 works be chosen from the same artist's collection? So you have to first isolate the artist. Isolate the artist, and then build out of there. I didn't see the same. Okay. Okay. Any others will be okay?
Yeah, I didn't get 15, 53. I don't think they're like at most. I told you that I got that.
All right. Let's look. If I do one of them, they're all kind of the same. To be honest with you. All right. You are going to go to Great America, and they have 20 different rides. You want to ride on at least 15 of them. How many different combinations can you go on?
It's a big number.
22.
I'm just kidding.
So what's the fewest amount of roller coasters you're going to go on?
15.
So how many of them do you have to choose from? 20 choose 15. 20 choose 16. 20 choose 17. I'm not multiplying though.
Yeah, see, that's
I'm adding between here because you want to be able to go on at least that many. So one thing, you could go on 15, you could go on 16, you could go on 17, you could go on all 20. So you add.
Yeah.
It's a lot of numbers.
Together was annoying.
It is annoying, but you'll get over it.
I know.
I get 2 words for it. Wait.
Did anybody actually do that right and tell me what the answer is?
It's 9.
Sorry, what? 21? Like the first one. 21, not a specific letter.
Because that's the kind of stuff you think about when you're going to go to Great America.
How many different combinations can I go on?
I mean, you're gonna
Someone else asked, was talking about this the other day. I honestly can't remember the last time I went to Great America.
Summer. We only rode rides.
I don't think I was driving when I went to Great America last.
Oh my goodness.
I think I was.
It's like not even.
They're not tall enough.
Yeah, Mr. Murphy, want to go to Great America as a class?
You can go on the.
We can figure out.
Yeah! It's with the curriculum.
Try to get that one through. So, yeah, we're going to go to Great America to test the combination theory.
Going down the drops, like whoever else taught us, like math questions.
The fish?
Yeah.
I didn't get it. I got 120, but then it said 958, and I was
You have to bring the fish with you.
wow.
Did everybody see the categories next to the words about the fish?
Yeah!
I know having to look for more than one place to find something is difficult for people. I know I ask a lot, but you know, what are you gonna do? From a list of different species of fish shown, an aquarium enthusiast is interested in knowing how compatible any group of 3 or more different species are. How many different combinations are there to consider? Well, there's one of, well, how many are there? 10 of them. How many do we want to look at?
3 or more.
10 or more? 10 choose 3.
10 choose 4. Can I just like do like that and all the way up to like 10?
Is there like a button in our calculator?
Or, what's another way I can do it?
I don't know.
What's the biggest combination you're going to get out of here?
10 is 10.
So if I take 10, choose 10.
Oh, mine is 10, choose 2, mine is 10,
And?
choose
0.
What we're doing, there's another way to do this. This is the way that we talked about yesterday. Add them all up. Yes, it's a pain. There's no button that'll get you all through all of it. It's not a difficult thing to do. You're in the calculator. That's why I didn't bother with it, to show you guys the way of working it backwards through subtraction. If you have a long train of things to look at, and you're starting at a relatively low number, there are only 3 other options. 10 choose none, 10 choose 1, 10 choose 2. Do you agree? By taking those 3 sums and subtracting it from 10 choose 10, you're finding kind of in essence what the complement is to it.
So the negative?
Yeah, it's kind of like the opposite of it.
Yes.
So it's a quicker thing to subtract those 3 as opposed to adding them all up. To be honest with you, just use your calculator and add them all up. You will be less likely to screw up.
So it'd be 55?
You know, it's
Oh, wow.
Okay? It's just another way of doing it. It's not a big deal. Sometimes it's a little bit cleaner. Sometimes people just go that way.
Say this is
You can go either way. 10 choose 10, then add them all up. 10 choose 3. I would start at 10 choose 10, then I can subtract quantity. 10 choose nothing, 10 choose 3. Did you put them in parentheses? You have to add you'd have to add the 10 choose 0, 10 choose 1, 10 choose 2.
I just 10 choose 10 minus.
How long is facial expression when he does
I do like 10 choose 10 minus 10 choose 2 minus. And then like I do it.
And it's like.
Oh.
And I got.
That's what I got.
Oh, then, I don't know why I didn't do that. Just add them up, it's quicker. Well, the compound worker, you're not supposed to set it to 0.
Well, I did it at 40, 54, and I got a negative number.
But it's,
What is that?
oh well. Alright, take this one, because I want to add to it tonight, okay? Alright. Let's talk about binomial expansion in Pascal's triangle.
Pascal. Is he like a specific person? Or
No, yeah, it was a guy.
A guy.
He's old, he's dead, he had years.
Hey, we read one is a hero. No.
Pressure.
Did we read about Pascal and G?
Pascal?
I should, but this guy's name is
Pascal.
Blase.
That's the one.
He was really boring. Is that how you pronounce it? Blase? Blaze? Hey, yeah.
Waves.
Yeah, Blaze.
I will say one thing, Caleb. When you and Colin walked by me and Ryan yesterday, Ryan turned over and goes, "Oh, hey guys, I'm here to see Miss Emily." I thought that was the funniest
Oh,
thing.
yeah. I was like, wait, see. What did you say? Oh, and then you said it. And I was like, what?
We walked by, we were walking to the soccer game. I'm holding our littlest Ryan's hand. A couple of girls that are on the soccer team at Canelan do the the development classes and all that stuff. So they run the preschool. Ryan has a crush on Miss Emily. Miss Emily is a soccer player, and Caleb walks by. He just turned on. Sorry, I think she was the one that dove into somebody. 16. She was 16. I remember that's what it was.
She's never.
It wasn't her. But so Ryan looks over and goes, "Hey guys!" He's just all excited. How are you here to see Miss Emily?
Yeah. I was like, I heard him say Emily, but I didn't know who Emily was. So I was like, and then you said it again. I was like, oh, I like that exterior.
Yeah. So this guy named Blase.
Blaze.
Blaze. All right, Blaze. Blaze. What? You guys did this. Some of you guys did this project with Seb, where you worked with Pascal's triangle.
Oh, that was terrible.
What happened here with the Pascal triangle? I don't know if you guys, when he introduced it to you guys last year with the pattern recognition, if he showed it to you in terms of combinations.
No.
He just did the numbers, right?
I don't think we needed that.
Well, what happens with the Pascal triangle, if you look at just the numbers themselves, before I bring back to here, you don't have to write all this out. You have ones going on all of your diagonals here. What happens here, to get the numbers in the middle, I want you to notice that you have these two numbers added together give you what? 2. These two numbers give you what? These two numbers added together give you what? These two give you?
4.
These two give you?
6.
These two give you?
10.
These two would give you?
15.
And so on. That's how Pascal's triangle works.
It does.
15!
We're like,
That was
I don't even know. Because it'd be like a exclamation point, then
It was so awesome. It was so awesome. She fell out of the chair.
Yeah.
She turned bright red. Who? Jaeger. It was so funny. I scared her. So what happens here is that this all comes from combinations. 0 choose 0 is 1. 1 choose 0 is 1. 1 choose 1 is 1. 2 choose 0 is 1. 2 choose 1 is 2. And so on and so forth. This pattern is what allows you to come up with Pascal's triangle. Not only does this pattern allow you to go through Pascal's triangle, it also allows you to find the leading term coefficients as well as the exponent values of binomial expansion. What I mean by that is that we're going to be able to take a binomial, x plus 3 to the 6th power, and use Pascal's triangle to come up with all of the coefficients and all of the exponents without FOIL. It looks like it's going to be awful. It does. But it is so stinking simple. It is really, really simple. What is the degree that I need to raise this all to?
The 6th and 7th term.
The 6th, it's the 6th. So it's the 6th degree. It's the 6th degree. Now, Phoebe, I'm going to save you on this one. How many terms will the 6th degree have?
7.
7. That was what you were getting ahead of yourself for. Does everyone remember that whatever your degree is, you'll have one more term if it's binomial because you have a constant?
Yeah.
We'll have a 6th degree, 5th degree, 4th, and so on. We're okay on that?
Yeah.
So I know that my exponents, when I lay them all out, it's going to be a 6, 5, 4, 3, 2, 1, and then a 0 from the constant. Now, as far as my leading term coefficients are concerned, and all the rest, they follow this exact same pattern. It's pretty crazy how this works. Here's what we did. We know that we have an exponent of 6. You know what, I'm going to make this to the 4th so it's a little bit, so you might see it a little bit easier just to start with. Okay, just change it to the 4th. It's a couple of less steps. If it's a 4th degree polynomial, how many terms will I have? So we know we're going to have 5 terms and we're done. All right. So here's what we do. We take 5, choose 0. That will be the leading term coefficient. Now I take the first term. What's the first term here? X. It's going to be raised to whatever this power is. What's the power? X to the 4th.
Is x being multiplied by 5 to 0?
Yes, because 5 choose 0 is going to give it its coefficient. I'm going to show you a shortcut. It's easier to see it my way first. Just trust me on this. Now, the second part of this binomial is a 3. I'm going to raise that 3 to the 0 power. So this part right here, 5 choose 0, x to the 4th, 3 to the 0, is the first term in my 5-term sequence.
Oh.
Wait, why do you make it 3 to the 0?
Because that's what's going to happen here, Phoebe, is that I want you to see that if my term here is a 4th degree, the first one's going to be a 4th, a 0, the second will be a 3 and a 1, the third one would be a 2 and a 2, third one would be in the a 2 and a 1, and the last one would be a 3 and a 1 and a 3, and then a 0 and a 4. What's happening is each of these values, the degrees for each of the consecutive 5 terms are going to change to get the different powers on it.
Oh, I see.
All right, got it.
If the first term before the C is n, why is it 4?
Oh, did I make 5? I'm sorry. Yes, it should be 4. My bad. I'm sorry, guys. I must have said there were 5 terms that I just wrote down. It was just a simple mistake. Okay, thank you. So now, the next term would just be, well, it's still going to be 4. This is 4th degree. It's 4, choose 1, x to the 3rd, 3 to the 1st. I dropped a degree, I added a degree.
That makes sense.
The next one would be 4, choose 2, x squared, 3 squared. Drop a degree, add a degree. See the pattern now?
Yeah.
See why it's a heck of a lot easier than trying to write all that out?
Yeah.
The next term would be 4, choose 3, x to the first, 3 cubed, plus 4, choose 4, x to the 0, 3 to the 4. That's how you can expand out higher degree polynomials quickly. Some of you might have seen this on if you've taken an ACT at some point in time, they might ask you what is the 4th term in an 8th degree polynomial, because they're going to ask you to do this. This comes up pretty often on ACTs. Okay? It does show up.
That wasn't.
It was?
Yeah, I didn't like that.
This is how you would do it quickly, otherwise you probably had to FOIL the whole thing out or just go eeny, meeny, miny, moe.
Yeah.
So what's 4 choose 0?
1.
1. You get 1, so it'd be 1x to the 4th. So I'm just going to get rid of the 1. 1. Okay?
What?
And be
What's 4 choose 1?
1.
4.
Is it 4?
Yeah.
Okay. So it'd be 4x cubed times 3.
12. Oh.
I'm just going to write it out each part first, then I'll combine terms in a second. The next one, what's 4 choose 2?
12.
Wait, how do you guys?
Yeah, are we supposed to
Because
know that? or
it's
is
like
it
the
just-
4 and the 2, you're choosing 2, so it'd be 4 times 3. And 4 times 2 is 12.
Or are you talking about?
It's like the 4 with the exclamation.
Oh, wait, no, that's the other.
Remember, this is 4 factorial over 4 minus 2 factorial times 2 factorial
Yeah, which means it's just 4 factorial over.
over, it's 4 factorial over 2 factorial, 2 factorial. So it should be 6.
6?
Yeah. Because if you look at it, this is 4, 3, 2, 1, 2, 1, 2, 1. So 2 times 3 is 6.
Oh, I forgot.
You're thinking about it in the other one, the permutation, okay? And I will tell you one thing. You're gonna know what 4 choose 2 is in like a day because you do these so often. It's the same number every time. Okay. So the next one we wind up with 4 choose 2, which was 6 x squared times 9. You okay on that?
Yeah.
4 choose 3. Well, 4 choose 3. Well, remember that's 4, 3, 2, 1 over 1 and 3, 2, 1. So it would be 4.
Yeah, dang it.
4x times 27. You okay with that?
Yeah.
And then the last one would be 4 choose 4, which is 1. X to the 0, so that's still a 1.
And
And
then
it's 3 to the 4th, which is 81. So now you just go back and multiply it out. We get x to the 4th plus 12x cubed plus 54x squared plus 2054, 108x plus 81. And you're done. It's more fun than a barrel of monkeys. And a barrel of
Those are pretty
monkeys would be
fun.
quite fun. Unless it's like a really, really big monkey and you're on ladders and it's throwing barrels at you.
Just say one.
Thank you. Nobody else got that? Thank
I
you.
got it. I shouldn't laugh as loud.
Donkey. Donkey
Let's try another one.
Okay.
Because I just did that one I wanted to do.
Is that all it is? Is that like all binomial expansion is?
Yep.
What if there's subtraction? Like x minus 2 to 6.
Because you just have to remember that you have to put that one in parentheses when you're changing your degrees. You want to do one like that?
No, I mean, yeah.
Like you just do.
All right, just x minus 2 then.
Negative 2.
So your second term here is -2 now, instead of a +2. So the problem you'll have to come across when you're raising whenever you have the odd exponent on the 2, you just gotta make sure it's a minus sign then, okay? That's all you have to be careful with. That again. So that's my second part of my binomial is -2. Whenever I raise -2 to an odd exponent, it's always gonna be a negative value.
And then you
Just-
add.
Yeah, you just gotta be careful with them, okay? So here you wind up with 6 choose 0, x to the 6, -2 to the 0, 6 choose 1, x to the 5th, -2 to the 1st.
Are there shortcuts?
This is the shortest way of doing these things. I promise I've tried not to give you anything bigger than a 6, if you have to multiply it all out. But like on ACT though, I might say, if this is x minus 2 to the 16th power, I'll say, what's the 12th term? What's the coefficient of the 12th term?
Wouldn't that take forever?
No, because what I have to do, I'll show you that next.
It's gonna happen, it's gonna happen.
It's not. Choose 4.
Oh, so would it be C, 12, C11?
Yeah. Or whatever we're going to do. Whatever term I asked you for. I'll show you.
Got it all in one line, bro. Me too.
Did not get all in one line.
Got it on 3.
And then just put them all together. Okay? Just be careful whenever you're raising your exponents with the negatives. Make sure you have the parentheses. So you wind up with, let's see, x to the 6th minus,
Why'd you put the 2?
huh?
I put x to the 6.
Isn't it negative x to the 6?
What is -2 to the 0 power?
Negative 1.
1. Just put it in parentheses.
Yeah, no, I forget the calculator.
Put it in parentheses. That's why. Remember, anything raised to the 0 power is 1. So then you have -2x to the 5th. 6 choose 2. What does that mean? 6,
It's 15.
5. Is it 15? Thank you. So it'd be 15 times 4x to the 4th. You okay with that? Because -2 squared is 4. The next term, is it going to be a positive or a negative? It's going to be negative because it's an odd exponent. 6 choose 3 is going to get me 6, 5, 4 over 3, 2, 1, so it'll be 20.
I got it.
Yeah.
But yeah,
It's
Wait.
20.
Odd exponent.
I checked in the calculator.
Too late.
20 times.
Except if you.
Here's how I did it in my head.
It'd be
It's
negative.
6, 5, 4,
No, I
3,
understand.
2, 1
Negative.
over 3, 2, 1, 3, 2,
Negative 1.
1. I knew those were going to drop and these came to here. I just knew that.
I knew what you mean.
Okay.
What's 3 to 3?
No.
I get it.
Nope, nope.
And then you wind up with
Negative 1.
6 choose 4 would be
15.
6, 5. How much? I can't. 15.
Wait, what?
It's 15
Yes.
times, would that be 16 minus 6 choose 5 is that 6?
Yeah.
Is it 6?
Oh, wait, no. Oh,
6 choose 5 is 6.
I'm
Wait, I
pretty
got it.
sure.
Yes, it is. Yeah, it's 6.
Yeah.
6 is 1.
Well, this is fun.
And then
Negative 32.
I just don't like,
Wait, where'd you get 64?
2 to the 6th power.
Oh, yeah, I thought it was negative 2.
Put it in parentheses.
Yeah.
And then it's matter of putting them together. Okay?
Just remember when it's even, next one is gonna be easy.
Oh, and I love these words.
Wait, our cars are gonna be at the junction. I thought he said no. He's like, can we breakfast and then we go on the bus?
Wait, I thought, so we don't
No, if you want to add on to that, that's fine. Let's do this. There's a B and a C side. Let's do, on the B, 5 through 9, 13 through 17. And then on the C side, I think it's 5 through 9, 13 through 17. Do the same on both sides. All right? It should not take very long. It should not take very. Don't do it on here. Don't do the binomial expansion on this sheet of paper. You won't fit it. Just add your homework from the other night, and we'll stay them all together. All right?
Black card.
I suppose so. But what if I can't?
You know what? If you can fit it, that's great.